All right, how's it going, everyone? This is Brian, and welcome back to the Tech Stack Playbook, your guide to apps, software, and tech, but in a fun way, I promise. So in the last video, we shipped an absolutely epic build. We built in 2 hours our own large language model, and we used Meta AI's Llama 2 to deploy to Amazon SageMaker with Hugging Face deep learning containers. And it was really exciting because we were able to take a model that lived in Hugging Face, we're able to import that into Amazon SageMaker, and then we were able to work with our own large language model and ask it questions. Now, this was pretty exciting because we were able to use one of the largest large language models available to us on the internet. We built this model, it's a 13 billion parameter LLM, and we were able to start asking it questions right from the SageMaker studio. So what we were doing was we were really leveraging the Jupyter Notebook environment that SageMaker sets up in the studio. So when you launch your SageMaker domain, you're able to then create these instances with servers to then run Python scripts that run code that you could work with, an AI or a machine learning model or a data set. And that's really exciting because it allows us to work with a large language model directly. Now, the issue that comes up once you've deployed your model to Amazon SageMaker is, how do I get this into a real working application? And this was something that I don't think is often talked a lot about or explained a lot online, because sure, we can run our cells in our Jupyter Notebook and that can work, but how do we get this out of Amazon SageMaker, or if you're using Google Colab, or if you're using any of those other model deployment softwares? How do we then allow a system outside of our SageMaker environment or our Colab environment? How do we then interact with our model? And that comes up when we're trying to build applications. Maybe we're trying to build microservices. Maybe we're trying to allow us to write scripts that could interact with our model. Maybe we're running something locally or on our computer. So how do we get our model out of SageMaker and into an application? This was a question that I was trying to learn about and build, because there's many different use cases that come up and I wanted to explore all of them. So we're going to explore several of these in this video. Now, to get our model out of Amazon SageMaker, we're going to be configuring 2 different sets of integrations. One of them is going to be on the cloud side, and then the other is going to be on the application side. For the cloud side, what we're going to be doing is we're going to be learning about API Gateway to create an API for our model, and then we're going to use AWS Lambda to configure serverless scripts for running the model. And this is going to be really interesting because with the API Gateway route, we'll be able to create a completely usable API that could have authentication if you wanted to. It could be open access with certain parameters. You could configure different stages, and that will allow us to bring our API into our model. Now, with the serverless function with Lambda, what we're going to be able to do is then write scripts that could do response request to our model endpoint and then back, so that we'd be able to request data and then return data. So these are going to be 2 specific ways that we'll be able to customize on the cloud side. Now, on the application side, what we're going to specifically do are 2 sets of things. We're going to be configuring a Python script to hit our endpoint and then be able to get requests back. And then we're also going to build a Next.js TypeScript Tailwind CSS application to build an application to service our model, but it's an application model that can interact with these AI and ML services directly. So this is going to be a really, really great video for anybody that's looking to basically, how do I take my model that's running in AWS and then start throwing that into microservices, APIs, applications, outside of the AWS environment. And I think this video will be really helpful for anyone that is wondering about these topics, because of course it's cool to run, Jupyter Notebook and run cells, but when you're building a real application, you need to know how to allow users to interact with your model, not just allow developers to be able to access the model. This opens up access to a world of possibilities. And another area that is going to be really cool is that we're going to build a pretty cool Llama chat application where we'll be able to really write in a prompt, then press a button, and then we'll be able to get a response back as if you were talking to ChatGPT or Google Bard or Hugging Face chat. So we're going to build our own mini ChatGPT but with the model that we deployed in Amazon SageMaker. So this video is going to be packed with a ton of helpful information. And before we get started, if you could just absolutely obliterate that like button and hit that subscribe button, it helps the channel a lot, and you'll also get notified when we go live. And I've also heard that when you like the video and subscribe to the channel, it actually boosts your AI and development productivity by at least 20%, if not 30%. It was a study I read online. I'm not sure if it's legit, but why not? Why not try it out, right? So yeah, if you could hit that like and subscribe button, it'll be super helpful for the channel. And also you'll get notified when we go live, and you'll be able to learn when we build cool stuff next. So with that, I'm really excited to be showing this video to you all and helping you on your AI and ML journey. So with that, I will roll the video next, and we'll get into all of those elements. So building microservices, APIs, and then also applications. So if you're excited to start building really at the center of AI and ML, watch this video for all of the great content that's ahead. So in the last video, something that we did was we deployed Meta AI's Llama 2 model onto our Amazon SageMaker instance, and then we were able to hook up an endpoint to be able to talk to our large language model. So something that I'm going to show you in this video is how to connect a Lambda function or an API to your model so that you can use applications to interact or write scripts to interact with your model. Because right now we're just doing it in Jupyter Notebook, which is fine. But if we want to actually extend this outside of the model, inside of the notebook, and then into some applications or some scripts, because obviously we'll be probably working on code where users will need to interact with the scripts, or we might need to invoke them somehow and then get responses back. So we're going to go through how to actually do that. And what's kind of interesting was, as I was writing this Lambda, I was actually trying to use Llama as a debugging buddy. And one of the issues that I had was, and I used as a prompt, "You're a coding expert, highly skilled with AWS and Lambda functions." And I was writing this code, and I was getting basically this issue. So I wasn't able to deploy it or get the model that was deployed to connect to the function. And I was able to share this error. And it wasn't a very helpful error. It just said that query string parameters key error. And basically, can you help me understand what this error is saying? So then as I scroll down, it was able to say, sure, I can help you with that. Can see that you're having an issue because of query string parameters, key doesn't exist. And basically what it was able to do was help me understand that I needed to change the value that I was fetching. So that was kind of cool because it was picking up on something. And also at the time, ChatGPT was down. So this is probably one of the best reasons to have your own technology, because then if other systems are down, not available, you're empowered to use your own tech. And this was really helpful, and it helped me fix this error. And then another issue that I had, which I was testing, was how to turn this into human readable text, because it comes up as a string. You can kind of see that in the prompt right here, where it talks about in the body, and then it has, this enter, and then it's just this really long string, a lot of enters, like // and all that stuff. So I was asking if it could turn it into human readable code and text. So it was able to do that, and this was a recipe. So what was really cool was that I was able to use this as a debugging buddy while I was writing these functions. So I think that this will be really helpful to go through how to get your model outside of Amazon SageMaker and Jupyter Notebook and into some applications. So we'll go through a couple of those methods. So the first thing that we're going to do is we are going to open up the AWS Management Console, and we're going to go to Lambda so that we can start writing a function to interact with our endpoint. So what we'll do is that we're going to create a function. We're going to author it from scratch, and we'll call this llama2, and we'll say lambda function, or actually we could just say llama2 lambda prod. And for the runtime, what we'll do is we'll click that, which is Python 3.11. x86 64 is all good. And we could configure some of these other things. We'll do some of the stuff later. These are some other advanced settings that you could set, but we aren't going to need to do that right now. So we're going to do create function. This will take a couple of seconds to set up. And then once it's set up, now we have an environment where we can start writing some code. So I'm going to zoom in here, and this is what it looks like. So in terms of the code editor inside of Lambda. So to get started, what we're going to do is we're going to go back to our endpoints in our Jupyter Notebook. This is the name of the endpoint. So we're going to copy that. We're then going to add that as an endpoint after we import Boto3. And that's going to allow us to connect to our AWS resources. So we're going to call this endpoint name. We're going to configure a runtime, and that's going to be boto3.client, and then runtime SageMaker, and then content type, that's going to be application JSON. Okay, so then we're going to define our Lambda handler function, which is going to take in an event and context, and then we're going to, instead of to do implement, we're going to do create prompt. So this is where the user is going to be inputting something. So we're going to say user input equals event, and then query string parameter. And if you remember from the video that I just shared, I was getting an issue related to this where I think I had query string parameter, and Meta was able to tell me that you might want to check if it's parameters or parameter. So just an example of how I was able to use my own LLM to help me with writing some code, which was pretty cool. Now we're going to also, and I'm going to just change this to be input, and then query for model. This is going to equal user input dot get, and then query. Then in the payload, we already have this code from our model, which is in here. So if we go back to our payload, so this is our payload. This is the input data. So we'll go back to our Lambda, and we just want the inputs and the parameters. So we'll put that in here. Just format that a little bit nicer. And that's how we're going to be running this. And also just important to note about the max new tokens. We want to make sure that this is a lot so that we're able to get a response back and it won't get cut when the tokens come back from the model. And to finish converting our payload to go from the Jupyter Notebook to Python script, we're just going to add in our query for model in this spot where previously we had prompt in the Jupyter Notebook. So now this is going to be query for model. So now what we're going to do is we're going to continue along. We're going to then log our response. We're going to use our runtime with the invoke endpoint method. And that's going to be the endpoint in SageMaker. We're then going to make the endpoint name equal to endpoint name. Content type is going to equal content type. And body is going to equal json.dumps payload. Cool. So we'll give this a log with print. And then we're going to decode this message into a UTF-8 output. So we'll say response decoded equals JSON loads response, pull out the body, and read, and then we'll decode this in UTF-8. Okay, and then we're going to show the entire response from llama, and this will be the final response equals response decoded, pull out the first one, and then generated text. All right, so that's pretty much the script, and then we will just update the return statement. So this will be a 200 status code for OK, and then headers. We're going to give this a access control allow origin. So you can configure this to be more secure if you wanted to lock this down in production. But since this is just a practice example, we're just allowing control access to anything. But obviously, if you're using this in a production app, you would want to close this down more. But since this is just for practice and for example, we're just allowing this with the wildcard to allow any type of response. And then we don't want to return the hello from Lambda. What we're going to do is we're going to return the final response. So we'll give this a save. We're going to give this a deploy. And once it says successfully updated, then we know that this is the current state of the function. So then what we're going to do is that we are going to, in the next step, go to test. We're going to configure a test to run our Lambda function and see if it can speak to our SageMaker endpoint. So now when we go to test, what we're going to do is we are going to create a new event that we're going to use to model how we're going to be talking to our Lambda function. So what this is going to look like is when you go to the event, you're going to give it a name. So we're going to call this llama event testing object. It'll be a private event. And this is just the template for hello world. And then what we're going to do is we're going to get rid of these values in here. And something that we are going to do is we're going to configure some parameters for this. So there's going to be an HTTP method, and that's going to be a GET request, because we're going to be reaching our endpoint to get information back. There's going to be a path, which we can just make as example path. There will be a query string parameters value, and it's an object. And what will be under that will be a query. And that's going to be what the user submits. So in this case, we're going to create our own prompt. We're going to say, please make an absolutely delicious recipe for someone who likes desserts. Then user input 2 can be value 2, because who doesn't like desserts? And we're just going to fix that spelling. Cool. So what we're going to do is we are going to give this a save. But before we do that, we are not going to test this yet because we're going to get an error. But we could actually test this, and we'll debug this in a bit. But there's going to be a few more areas that we need to configure for our Lambda function to actually work. But it might be helpful for you to see why we'll get some certain errors. So we'll do test. And then it's going to fail. And it's going to say that there's an error invoking the endpoint operation, which is this endpoint. And it's talking about this identity-based policy with SageMaker invoke endpoint action. Now, the reason why we're getting this is because we haven't configured our Lambda function to speak securely to our SageMaker endpoint. Basically, there isn't a relationship between our function and our SageMaker endpoint. So what we're going to do is we are going to go back to our Lambda function. We're going to go to configuration. We're then going to go to permissions, and we're going to go to the execution role. Now, this is really important because when you configure relationships and roles and permissions for your execution role, this is all going to be in JSON. So what we're going to do is that we're going to edit this. We're then going to scroll down, and when we say view this role, this is going to now pop up IAM, and we're going to be able to now see this role. And we see that it has some basic permissions here. Now what we're going to want to do is we are going to want to attach policies here. And what we want to do is, if you wanted to, you could find the policy, and we could do SageMaker, and we could attach Amazon SageMaker full access. But we don't really need to give it a lot of access. What we can do is that we can go back and configure a little bit more granular permissions for our role. So there's different ways to do this. I like to edit it in JSON. So basically what you would do is that you're going to give it a statement ID, there's going to be an effect, there's going to be an action, and then there's going to be a resource. And this is the basic function, basically the format for any sort of permissions that you're adding to the role. So this is just an example of, that specific role. Now what we want to do is we want to go back and we want to edit specifically the execution role. So what we'll do is that we will go to this role, we'll click on it. You'll see that this has this link right here. Now what we'll do is that there's a list of actions underneath this. So right now it's just allowing access to write to CloudWatch logs. Now what we want to do is that we want to go to the JSON, and this is the IAM role for this execution role. Now what we want to do is we want to add another function. So you see how these are different statements here. So we're going to add another one right after this, and this is going to be for SageMaker. So we will create some curly brackets, and we are going to configure a statement ID, and we're going to call this allow access to SageMaker endpoint. Then under the effect, it's going to be an allow, and then under action, it's an array, but there's only going to be one item in there, and it's going to be SageMaker invoke endpoint. And then under resource, this is also going to be an array, but there's just going to be one item. And what we're going to do is that we're going to go back to our Jupyter Notebook. We're going to go to our endpoints, and we're going to copy this value here. Give that a copy. We'll then go back to the resource, and we're going to paste this ARN into the IAM role. So now this ARN is given the resource, and this function is allowed to call the SageMaker invoke endpoint to this specific ARN, which is endpoint here. And that's the endpoint that we deployed for our model. So this looks great. We will go next. And now we are updating the permissions for our execution role. We'll give this a save. Cool. So now what's going to happen is now, because this is happening instantly, what we'll do is that we'll go back to test, and we can actually give this a refresh. So now we can see that this is configured with SageMaker and with CloudWatch logs. So that proves that what we just did worked, because IAM is extremely instant. So now what we're going to do is we'll go back to test. We still have the same test event. We're going to give this a test, but we're going to get another error, and you'll see why in a second. So we see that it's running, and it ran for a few seconds, and then it cut out. And the reason for that is that it timed out after 3 seconds. And this is specifically because Lambdas, usually the default is set to be 3-second timeout. So what we're going to do is that we're going to go to our configuration. We're going to go to general configuration. And you'll see here that the general configuration for our Lambda is 3 seconds. Now, this model will take about, maybe 10 seconds to run. So what we're going to do is that we're going to set this to be 30 seconds. And this is going to mean that there's 30 seconds of window before this Lambda will cut out. Now, when Lambdas are running, you could configure this to have a 15-minute timeout, but you also are billed for the amount of time that a Lambda function is running. So you just have to be mindful of that as a restriction around the limit, but then also that you're incurring costs as it continues. So what we're going to do, we're going to add this for 30 seconds. It shouldn't be more than that. We'll give that a save. And now we go back to test. Let's see if this can work again. So we will test again. So now it's past the 3-second window, so that means that that configuration worked. So it seems like the model is working. So let's see what it said. All right. So it looks like we are getting our endpoint invoked and it's getting a response back. So please make a delicious recipe. Dear friend, hope this message finds you well as a fellow dessert lover. I'm excited about this. All right. So decadent dessert. Here's a recipe. Strawberries, heavy cream, sugar, chocolate, all-purpose flour, teaspoon salt. All right. So this looks like it's working correctly. And then it says happy baking, my friend. This is so funny. So this is working. This is great. This is exactly what we wanted to do. So now let's test this again. Let's see if we can get a different output. So now it's going to continue to run again. All right. So please make an absolute recipe. Someone who's lactose intolerant. This is a chocolate mousse, and it has chocolate. It has almond milk. It has sugar, tablespoon cornstarch, vanilla extract. This sounds pretty good. I'm getting pretty hungry actually. Check reading all of this. All right, so let's test this one more time just to see what it can create again. And these are all unique recipes too, so this is pretty cool. All right, this is another one with no milk in it. Dark chocolate, almond milk, cocoa powder, maple syrup. All right. So this is looking pretty good. So this is like very creative. I mean, let's see if we can even do another one. Ooh, okay. So someone who likes dessert, especially cheesecake. All right. Yeah, I mean, it's getting very creative. So this is when we turned up the temperature for the endpoint to be deployed and working. This is where it's going to be pulling very creative answers. So this is where when it's bringing in sort of this descriptive language and emotion sounding words, this is where it's bringing in that highly high temperature type creativity into it. So it can build very great, prompts and responses, but that's also where it's coming from. If you dial back the temperature, it might be a little bit more cold. But, this is talking about tiramisu cheesecake. So this is, talking about espresso. This is ladyfingers. This is sugar, vanilla extract, mascarpone, whipping cream. Tons of great stuff. Okay, this is great. This is what's working. All right, let's try to do like a completely different one. Let's do, what is a roadmap to become a professional software engineer in machine learning? Cool. So let's give that a save, and then let's test that. So this is going to test something completely different. And let's see what it says. And you also might want to configure the timeout to be maybe longer than 30 seconds if you ever are prompting and it's taking longer than that. So just a heads up on that. All right, so this is giving us some very good information. So this is talking about machine learning, Python and R, be able to solve problems, learn machine learning fundamentals, TensorFlow, PyTorch, scikit-learn, practice real-world projects, using GitHub and Kaggle as practice, pursue education, stay up to date on the latest developments. Not bad. So this is just giving really great answers. And the reason it's a string is because that's the string that output. We could transform this to be more human readable, which we'll do in a little bit, but this is just to show what this looks like. So this is great. So now we're able to get our function and connect to our SageMaker endpoint, get a response, and then return that back to basically the place that requested it. So we have our Lambda function working, which is awesome. So now we're getting farther and farther away from the endpoint and closer towards a user application use case or an app or a microservice. So this is great. So we're on the right track here, and we're now able to be outside of the Jupyter Notebook and now be invoking our model, which is awesome. But now this doesn't exactly look like an application, right? We want to be able to run some scripts or some functions. So how exactly would we do that? So the way that we'll do that is we're going to configure an API for our function. And if you scroll up, you'll see here that this function, it doesn't have anything to invoke it really. It's when we do the event, we're basically forcing it to be invoked to then reach the endpoint. But how would we allow another user to invoke this function to then call our endpoint and get a response back? So what we're going to do is that we're going to configure something called API Gateway, and API Gateway is going to be a way that we can do those GET requests like we did in our test, but to an endpoint through an API. So what we're going to do is that with Lambda, it has a really great way to add a trigger, and what we'll do is that we will select a source. We'll say API Gateway. Click this. We're going to say create a new API. It's going to be an HTTP API. And in terms of security, when you're using this in a real production setting, you're definitely going to want to do create authorizer. We're going to want to auth gate our API gateway when we're actually in production. But since we are just testing this, this is going to be open. This means that anybody on the internet would be able to invoke this. So just be very cognizant of that, because if you're running a model, like an ML model, you would want this to be authenticated and wrapped. But I'm just doing this for practice purposes. So just like this would 100% need to be auth gated unless you wanted people to be, accessing your model and you have, restrictions in place to make sure that, certain people can only use the model, in certain ways or certain use cases, or maybe only for a certain amount of time. But just for example purposes, I'm just going to click open. There's also some other parameters here that we can configure. We might be updating some of these a little bit later, but something also to look at that we'll have to look at later will be cores and the deployment stage. So right now we're just going to set this as default, but we will need to revisit this and also cores in a little bit, but you'll see why. So when we say add, and actually let's configure a name for this that would be unique. So we'll say API Gateway. We'll do add. And then what it's going to do is that it's going to create this API gateway within AWS for our use case. And then we now have a trigger that hits this API endpoint. So when we invoke this API endpoint, we then would be able to call this Lambda function to then call our SageMaker endpoint, get some data, and then send that through the API gateway back to where it was requested from. So this is now getting more into that solution architecture of response, API gateway, Lambda function, SageMaker, back to function, back to API gateway, back to the requester. So this URL is going to be very important, and you'll see why in a little bit. But here's some details about it. And this is what we just configured as well. But it's this API gateway.amazonaws.com, and we're going to be able to use this to make some calls to our SageMaker endpoint through this API. Now, one of the ways that we can start using our API endpoint is by using the URL directly, because we have it open to call. So what we're going to do is that we're just going to click on this URL. Now, we say message internal service error, and that's because we're not calling anything. So what we're going to do is that we're going to add in a query parameter with the question mark. We're going to say query, and then we're going to say, write me a clever rhyming poem. Now when we press enter, it's going to convert that into a string. And now we're able to get some responses back. So I'm going to zoom in a bunch so that you can see what it says. So I asked for a clever rhyming poem, and it says, sure, here's a clever rhyming poem for you. There once was a girl named Sue, whose cleverness was quite true. She loved to rhyme and play with words that danced all day. Her poems were full of cheer, and her rhymes were always near. She'd write of love and light and the beauty of the night. So feeling this, I mean, this is just so cool. So this is literally, like a large language model creating a poem. Now let's think about write a powerful LinkedIn headline for a college graduate trying to get a job in tech. So that's pretty specific. So let's see what it comes up with. All right, so powerful headline for a college graduate to get a job in tech. Here's some powerful headlines. So it's giving some examples, it seems. So number one, so recent college graduate with a passion for tech, seeking opportunities to apply my skills and knowledge in a dynamic and innovative environment. Number two, tech savvy recent graduate with a proven track record of success, software development, data analysis, and digital marketing. So this is interesting. So it already knows some areas that it knows are very popular. Seeking a challenging role that utilizes skills and helps me grow. Number three, college graduate with a degree in computer science. So this is really cool. So we're able to just get text output. So we're getting closer now. This is how we're able to now start, again, kind of going even outside of AWS to now be able to get that data from within the cloud outside of the cloud. So this is cool. So this is way number one, where we'd be able to invoke our API endpoint, hit Lambda, get data from SageMaker through the endpoint, pass back to Lambda, pass back to API Gateway, and then to the requester. A second way that we could call our API endpoint to reach our SageMaker endpoint is by writing some Python. So I'm going to open up a code sandbox, and we're going to open up a Docker container. And what we're going to do is that we're going to configure our code sandbox Docker container to be able to invoke our AI endpoint. So we'll wait for the micro VM to spin up, and we'll wait for Docker to be ready, which it looks like it is. And we're going to install some extra additions to our container here. So after update, after install, after HTOP, we're going to install Python 3, and we're going to install Python 3 pip. Then we're going to install some extra stuff. So install required Python packages via pip. So as soon as we added pip up there, we're then going to run pip3 install requests os.json time. And these are going to be some packages that we will use in our two Python functions that we will write. So we're going to give this a save. It already is going to detect that the Docker needs to be, Docker file has changed, so we want to rebuild and restart the containers. We'll say yes. So now it's going to stop the tasks and start rebuilding. So just give this a minute to do that. Cool. So it's running the containers, and it's getting everything set up. So you'll see here that the Python 3 and the Python 3 pip, those were just installed because we updated the Docker file. And now this is happening automatically. So this is a really great way where we can use Docker to programmatically set up our container environment. And we don't need to run, a whole bunch of scripts. This can just happen automatically when we spin up the container. So I'll bring the video back when it's all finished installing. All right, so now the Docker file has finished prompting all the updates and the installations. So now we can get right to work. So what we're going to do is we're going to create a new file. And that's going to be in the root directory of files. And we're going to say send prompt.py. So then what we're going to do is that we're going to create a Python script to invoke our Lambda function, but we're going to be calling our API gateway endpoint to call our Lambda, to then call our SageMaker endpoint. So what we're going to do is that we're going to first, I will make this much bigger. And then I'm going to import requests. Then we're going to define a main function, like so. And then the URL that we're going to invoke is going to be that endpoint. So we can go back to this. We can copy our API endpoint. And then params, so you have a query, and that's going to be what we just had before. So write me a clever rhyming poem. Cool. Then under the response that we expect, look at requests.get, and then URL with params equal params. And this will be our get request to this. So it's passing in this and this into the request. Then what we'll do is that we will print the response.json, and then we will invoke this function where if name equals main, then main is invoked. Cool. So we'll give this a save, and we're going to try to invoke this. So let's see if we're able to do that. So the startup tasks just completed. I closed out of that terminal and I opened up a new one. And by opening up this new one, we should be able to access the Python that we just installed. So we'll try that. So Python version. And it's saying that it's not installed. So something that we can do in case this doesn't work is we could do apt. So this will allow us to install the package. So we'll say yes. And then it'll install Python pretty fast in the Linux environment. Cool. So now if we try to write Python 3 version, we now see that. And we could also do the same thing with Python 3 pip. And that'll just let us use the pip installer for Python. And then we're going to basically do this pip install script here. So we'll say yes to that, and this will install this. So let's try that again. So we could also just try installing pip3. And we can also just try installing just normal pip. So then it found Python 3 pip. We'll say yes. And I wasn't able to find it. Interesting. So if we try to do pip, it doesn't seem to want to install it, which is interesting. So I'll try to see what that error is, but it seems like it's not finding it in the lookup, which is a bit weird. So something that we can try to do is we can do apt update and see if maybe that will help to prompt it. So we'll try to do that again. And we'll say yes. So it seems to be progressing. So I'm going to pause this video and then I'll come back when pip3 is finished installing. So that seemed to work. So doing apt update and then doing all of the scripts seem to have helped. So now if we do pip3 version, cool. So that gives us now the version of pip that we have. Awesome. So now what we'll do is that we will run this script to install the rest of the packages. So it would be requests, OS, JSON, and time. So now that we have installed the scripts that we need, we're going to then go back to our send prompt file, and we're going to execute that. So we'll do a new terminal. We'll wait for that to load. And then we will run Python 3 send prompt.py. So if this works, this should invoke our API gateway, Lambda function, SageMaker, pass back. And look at that. So now we have our poem. So write me a clever poem about a cat who likes to nap in the sun. So this is where it's now bringing creativity into it. It's a poem about a cat who loves to nap in the sun. There once was a cat named Patch, whose love for napping was quite a match. She'd find a sunny spot and curl up in a lot. Her purrs and snores were quite a hatch. That's so funny. So this is just created another poem. Like, let's try to do it again. Let's see if it'll make another one. All right, write me a clever rhyme about a bird. There once was a bird named Pete, whose feathers were bright and neat. He lived in a tree so tall and chirped his song for all. So funny. Let's do write a one sentence quote of wisdom. All right, so we're changing up the prompt a little bit. Try this again. The wisest thing I've learned in life is to always listen to my heart, for it holds the truest wisdom and guides me towards my greatest happiness. All right, I like it. Let's do another one. That was a good quote of wisdom. The only way to do great work is to love what you do. Steve Jobs. All right, cool. So now we're able to write a script to get these quotes, but they're just printing in the terminal. So how would we get this, again, outside of a computer environment? So we're going to write a script that will allow us to save the response to a text file. So let's do a new file, and we're going to say save response.py. All right, so we're going to install and import a few libraries. So we'll do import requests, do import JSON, do import OS, import time. So then we're going to define a main function. And we're going to basically copy that stuff from before. So this is that same function URL that we have from API Gateway. And we have our params right there. And the response is going to be the same, but the output is response JSON, and then print the output that we got. Then we're going to ensure that the responses directory exists because we're going to be saving it to a responses folder. So what we'll do is I will say ensure responses directory exists. Then we'll say if not OS path exists responses, then it'll make a directory called OS make directories responses. Next up, we're going to create a timestamp. So we want to order these files by timestamp so that when it saves the file, we don't want to overwrite it each time. So what we'll do is that we're going to say generate a Unix timestamp. And this is what we'll use in the file name to make them all unique. So timestamp equals integer time times a function. And then we're going to create unique file names with that Unix timestamp. So what that'll look like is file name equals f responses, so in that directory, and then timestamp, and then output.txt. And then we're going to save that output to a text file in the responses directory. So what that will look like is with open file name w as f. We say if output is JSON object, we're going to convert that to a string. If is instance output directory f.write JSON dumps output indent for, else we'll do a write. And then just to close this out, we will define if name equals main, then we will invoke main. Alright, so that seems like it should be all set to go. So what we're basically doing is we are creating a function that's going to create a directory called responses if it doesn't already exist, or it's going to find it. It's then creating a unique timestamp, and then it's going to append that to the timestamp output text file name, and then it's going to generate this. So every time that we get basically data from the output, that's where we're adding that to that file. So now if we try to run this, so Python 3, then we say save response.py. So let's see, so OS path responses, it did not like that. So give that a colon, try that again. All right, so now we see that this is the output. Right, what was the second method? Okay, cool. So that seems like it's working. And if we run this again, this should generate another text file, just like that. Awesome. And if we run this again, all right, let's try to run this one more time. So now it's giving different prompts. So this is where we could, if we wanted to spend more time, we could optimize to make it where it's only giving one quote, not like many people quotes. So this is where this is cool that we're able to then, generate, all these different outputs and text files, but where we could totally optimize the prompt to make it where it's only a specific sentence. But this is pretty cool. So this is now outputting all of these different text files every time that we run this model. Especially that last one that had all of the sentences in there, and it's formatted in nice human readable text. So yeah, it's giving all these different, sentences and quotes and whatnot. So this is really cool. So now we're able to see how we could, take this and log these out as text files. Now, something else that we could do is also create an application and invoke the function that way. So we're going to do that in the next video. So one of the best ways to go about creating application for a client to interface with a large language model would be to create, a Next.js TypeScript type application. So I'm going to open up another code sandbox, and this one is the Next.js TypeScript cloud box. So we're going to start up this micro VM, and we're going to then create our own app. And what we're going to try to do is run this API. So basically, we're going to create a function, but it's going to invoke that API gateway to hit that Lambda function to then invoke the SageMaker endpoint and then visualize it in the app. So if we're able to do that, then that's going to be pretty cool. All right, so we're just going to wait for this to spin up. All right, so this is the template for Next.js. Now what we're going to do is that we are going to close out a bunch of this because we are not going to be needing it. All right, so in our application right now, so we're using Next.js with TypeScript, and this is using the app router. So this is leveraging server components, and we also can leverage client-side components as well. So we're mixing server-side with client-side rendering, which is sort of a newer way of developing, which helps with fetching data, with optimizing load for deploying pages, and makes it much more of like a modern cutting-edge approach to app development and usability within applications. So what we're going to do is that we're going to create a application. It's going to be very, very simple, but it's going to have a text input. It's going to have a button, and then it's going to have a text box. And we will enter in our query. We'll then press fetch as the button, and then we'll be able to then prompt our SageMaker endpoint to return a value to our text box. So what we're going to do is that we are going to remove all of this stuff in home. This is just filler. So give that a save. And then something else that we're going to do also is we're going to remove all of these root styles. So now we won't see anything there. Okay, so now what we're going to do is that we are going to configure a few things. So on the page side, we are going to go back to here. We're going to configure a main section. And this is going to include our query box component. Now we're going to need to create that. So we're going to create that in components. We'll then create query box. And we're going to create zoom this out just a little bit so I can see. New file to index.tsx. And then what we're going to do is that we are going to import React. I'm going to use state from React. I'm going to say const query box equals a component, and this is just going to return this for now. This will just say test. And then we will export default query box. Then in page. Oh, and one thing, just it'll be important because we're using hooks. I'll say use client just to define that it is a client-side component, and then we will import query box from components and then query box. So now that should allow us to import that component into our home page. We're just going to wait for this to load. It might take a little bit of time, but now we see test. Okay, great. So now this is working. So now what we're going to do is that we are going to now start building out our query box. So it's going to have those three components. So it's that the text input, the button to fetch, and then the actual text box response as well. So what we're going to do is that we are going to do const query set query equals use state. So this is what's going to hold the query that we submit. And then we're going to say const response and then set response equals use state. And then we will console log the response just so that we can see what the response is telling us. Now for const, we're going to do fetch response. That's going to be an async function. And we'll put it in a try catch. We'll just say console.error. And then in our try catch, what we're going to do is we're going to do a couple of things. So what we will do is we'll do const data equals await Axios, and we're going to need to import Axios. So do that tops Axios from Axios. And something that we can do in the meantime is install Axios as a package. So just wait for this to boot up. We can work on this. So npm I Axios. So this is installing Axios for our application. And then something that we will do is npm I save dev types Axios. So now we're going to save the types that are associated with the Axios package as well. So there might have been an error just from the installation. So what we can do is restart. it seems like it's live, so we just need to wait for it to finish loading. So it looks like it's compiling super fast, and we're just waiting for it to load completely. In the meantime, we see that Axios is installed and also the Axios types. So this error should go away soon once it realizes that Axios is installed. Probably just because it's still loading. So what we can do in the meantime is we can keep working on that function. So we'll do axios.get, and then we're going to import that API gateway route function call URL, and then pass in params, query, and then we'll do console.log data from endpoint. That's data. And then we're going to safely remove everything before enter. So this is where there's going to be an answer. So it'd be like answer colon, and we're going to want to parse that out before get that. So we'll do data received parsed equals split data 1.trim and we're going to put that actually a little bit later. So what we'll do is we'll do const split data equals data dot split answer colon. Then we'll say let data received parsed, and then if split data dot length is greater than 1, then we're going to add that in there. And this is going to take the second part after answer. So second part after answer. Otherwise, we're going to do data dot received parsed equals data. Cool. And then under this, we'll say remove the prompt from the answer. And we'll say if data received parsed starts with query data received parsed equals data received parsed substring query dot length dot trim, and then under that we're going to set the response. So use that use state variable. We say data underscore received underscore parsed and console.log. We could log done if we want to, just to let us know that it's done, but it'll execute. So that's our function. It's quite a long function. And then what we're going to do is that we're going to want to configure that. So we're going to use Tailwind. We're going to try to make a nice application here. So I'm going to get rid of test. Do the div class name. We're going to do flex column items. Center justify center hScreen. And we do bg gradient to R from gray 900 via gray 800 to black, and then that's going to be container div so that's the background. And then what we're going to want to do is create a text box for that input. So there's going to be, so if there's a response, then we're going to create a text area that is read only with the value of response. And then the class name equals MB8 W64 H64 P4 border rounded large shadow large BG gray 100 and then resize none. And then we will close out this text area. And that should do it for the response text box. But since we don't have any response, we shouldn't see anything really in there. So then now we're going to create a container div for the text input that we'll type and then the button. So we'll say type div class name equals flex column item center. Close out that div just so we don't forget. And then we'll do input. The type is text because it's a text box. Value equals query. On change equals, and we'll pass in an event. Then that will be set query to event.target.value. And the class name of this text input field will be W64 P2 MB2 border rounded large shadow SM focus border blue 500 focus ring blue 200 focus ring opacity 50 and then placeholder enter your prompt ... and close that out. And then now we just have to add button. So create a button, and then on click, it's going to invoke that fetch response function. So we'll do fetch response, and then class name equals px8 py2 text weight bg blue 500 border rounded large shadow sm hover bg blue 600 do focus border blue 700 focus ring focus ring blue 200 focus ring opacity 50. Then we will say fetch. Give that a save. And then let's see what we got. All right. So we got some stuff. Cool. So now we have text input field and then a button. And something actually that we could do that could be kind of interesting is if we can make it where fetch changes to fetching when it's loading the data. So let's see if we can do that. So say const, we'll say is fetching data, and then set is fetching data. That'll be use date. And that'll be set to be false from the start. And we're fetching that. This will be set to be true. And then finally, set it to be false. So if is fetching data is true, then we'll say fetching, otherwise fetch. So I'll add that in there. Okay. So we're going to say, once this finishes loading on the server, cool. So we're going to say, what is the best programming language? So now it's fetching, and if we get a response back, we should be able to see it reply in a text box. So we'll just wait a few seconds. And don't see any response back. So let's see if it gave us any indication of what went wrong. All right. So it's been blocked by CORE's policy, no access control. So this is important because we are going to need to configure it to know that we're on this other URL. So I'm just going to expand this a little bit. So this is its own other domain. This is now a non-AWS domain. So before we were calling it in Lambda, and we were calling it from a URL. But what if we're calling it not from that URL? What if we're calling it from a completely different application? It's set to be secure so that you can't just access these types of endpoints or these types of routes. So what we're going to do is that we're going to configure our CORE's policy to allow access to call this endpoint from our application. So that'll be the next video. To allow CORE's policy to not get blocked by our access control allow origin header, what we're going to do is that we're going to go back to our Lambda function. We're going to then go to our API gateway that's configured, and we're going to go to CORE's. And what we're going to do is that we're going to configure some settings around this. So specifically the access control allow origin, we need to allow access to that application. So this application has this URL. So what we're going to do is that we're going to add that to the list of allowed origins. We'll add that, and we'll also access control this. And you could add all these other different parameters if you wanted to, but we're not going to do that, in this video, but you could if you wanted to. And then we'll do save, and then we're going to deploy, and then deploy to stage, but should already be set. We shouldn't really need to do anything there. But if you had like different stages in, you would be able to change that. But yeah, it says auto deploy is enabled, so we're all good there. Just if you have other stages, then you would need to deploy them. So now what we can do is that we can try to reload our application and see if we can request it again. So we'll try do another fetch. We'll see if this will allow us to call our endpoint. All right, so now we have some text coming back. So we see that this is logged in our console, but this is a text box. So there is not one best programming language. Here's some popular programming ones. So Python, JavaScript, Java, C++, Swift, Ruby, PHP, Go, Rust, Kotlin. So now we're able to speak to our SageMaker endpoint through API gateway to a Lambda function that then calls Amazon SageMaker and then goes back to Lambda, API gateway, and then our app. So let's see another one. Let's try, I need a 1 sentence of inspiration. We'll do fetch. Now it's fetching. And that was really fast. Okay, of course, here's 1 sentence. Your dreams are waiting for you, and with every step you take towards them, you grow stronger and closer to making them a reality. Ooh, I like that one. Let's try to get another one. So we'll fetch another inspirational quote. And now this says, believe in yourself and you can achieve anything. So this is giving us a bunch of them. Oh, this is great. Okay, this is really cool. And then, is time travel possible? So I want to find out because I've watched Interstellar. I love that movie. I want to ask Llama if time travel is possible, like in the movie Interstellar. So let's see if that works. Okay, in the movie Interstellar, character Cooper travels through a wormhole. He experiences time dilation and other effects. However, is time travel like this possible? The concept of time travel in Interstellar is based on the theory of general relativity, which describes how gravity warps the fabric of space-time. According to this theory, it's possible for objects to move through space-time in such a way that they experience time differently than objects that are not moving. This is known as time dilation, and it has been observed in experiments such as Gravity Probe A and the Pound-Rebka experiment. However, the kind of time travel depicted in Interstellar, where an object moves through a wormhole to a different point in spacetime, is still purely theoretical and has not been observed or proven. Wormholes are theoretical tunnels through spacetime that could potentially connect to two distinct points, but they are still purely theoretical and not observed or proven. Additionally, even if wormholes did exist, it is unlikely that they would be stable enough to allow for safe passage. Gravitational forces involved in maintaining a wormhole would be enormous, and it is likely that any object passing through one would be torn apart by intense gravitational forces. In summary, while the concept of time travel based on theory of general relativity is possible, interesting, so it's saying it's possible, the kind of time travel depicted in Interstellar is still purely theoretical and has not been observed or proven. It is unlikely that wormholes exist or could be stable enough to allow for safe passage. But based on the theory is possible. That's pretty interesting. So it says that it's possible, but we just we haven't seen it yet. That's pretty cool if you think about it. Okay, and then will AI take over humanity? Let's ask that. Let's find out. I wonder if Llama would be trained on this type of question. Oh, it gave a really long answer. Okay, so will AI take over humanity? The concept of AI taking over humanity is a popular theme in science fiction, but it is not a realistic scenario in the near future. Uh-oh. While AI has made tremendous progress in recent years, it is still a long way from having the capabilities and general intelligence of humans. Additionally, the development and deployment of AI is closely regulated and monitored by governments and ethical guidelines to ensure its safe and responsible use. There are, however, valid concerns about the potential risks and downsides of AI, such as job displacement bias and privacy invasion. These issues need to be addressed through careful planning, research, and regulation to ensure that the benefits of AI are shared by all and its negative consequences are minimized. It's important to note that AI is a tool, not a living being, and it cannot have the desire or intention to take over humanity. The portrayal of AI as a malevolent entity in science fiction is just that, fiction, and should not be taken as a realistic prediction of the future. In conclusion, while AI has the potential to bring about significant changes to society, it is not a threat to humans' existence. Rather, it is a powerful technology that can be used for the betterment of humanity if developed and used responsibly. That's a good answer, but very interesting. All right, so this is awesome. So we were able to now create an application where we were able to invoke our API gateway. API gateway could call our Lambda function. Lambda function could call SageMaker. SageMaker could then get a response back to Lambda, to API gateway, and then back to our application. So this is awesome. So we were able to create really a fully working application where we can add in a prompt here, we can fetch it, and then we're able to get a response back. So this is great. So this is now yet another way that we'd be able to communicate with Amazon SageMaker and our endpoint. So now that we have created our application, let's say that we want to take down our endpoint and make it so that we can start conserving resources, because right now this endpoint is incurring costs and we need to make sure that we are controlling for any, not use and just being responsible with our credits, because we're going to get billed for this instance and it's an expensive instance. So we want to make sure that we can cost control. So what we're going to do is that we are going to go back to our Amazon SageMaker dashboard, which is easily accessible through here. And then what we can do is that we can go to our inference tab. We can go to our endpoints and we see this one. And now we can delete this one. And then this will delete the endpoint and cannot be undone. This will affect other resources, but we will say delete. So now it's going to delete this endpoint. So now this won't be a running instance anymore. So we can still try to see if we can actually access through our endpoint. So okay, so this failed and it said bad response. So that means that the endpoint is terminated. So this means that since it's no longer working, it can't be invoked anymore. So even if we try to make a request through it, or what is today's date? So if we try to fetch it, we're going to still get that bad Axios request. So that just shows you that as soon as you delete this endpoint, we're no longer able to communicate with it. And even if we try to go to that endpoint, we try to click on it. We do query. What is today's date? Yeah, it's going to say message not found. So Actually, let me change this. Yeah, so internal server error. So this means that the endpoint is no longer accessible. We're not able to, use this anymore. And the SageMaker post, so we'd have to redeploy our endpoint with that same Jupyter notebook if we want to access that. So that's great. So this now means that we're able to make sure that our resources are also secure in case we ever need to lock anything down. We know that we're able to turn down the endpoint and then the application would stop working. But also just make sure that you know that if users are relying on these services, you would have to reroute them to a different route. So something that would actually be really interesting to just talk about very quickly would be that when we are looking at our endpoint here, so let's actually go to that. So something that you can do for stages that I think is pretty important is when you want to configure maybe a production or a development. So right now we just have one default. And let's say that we wanted to deploy a new one. So we could name it maybe dev. And this could be development related. And we could enable automatic deployments or not. Sometimes that might be helpful, but also maybe sometimes it might not. But let's say that we create it. So create a dev, we can deploy it. And we want to deploy, this is manual deployments, so we need to deploy it. So deploy to stage. So it added to stage. Now what we can do is that if we go back here, so now we see that there's a default and there's a dev. So now you'll see in the URL, it's /default and then it's /dev. And then let's say that we, had like other types of endpoints. That's where you could configure these different URLs to do different things. And they could maybe have certain, parameters, like you click on this, it's dev, and that means something different than if you click on this, it's default. So they could interact in completely different ways. And you could have, different variables, you could have different, deployment strategies, and that's where you could create, a production, version and also a dev version. And then like for stages, for example, say we wanted to do prod. So this is production level API. Maybe you had, like API key, and then this is like something. Then you could add a staging variable, and then you do create, and then deploy production. So then now, if you go back here, so now, for example, you could have a production, you could have a development, and you could have a default. And then if you go to this, you would need to add in that key or that value to the call for it to work. But you could also use different, authorization patterns as well and try to make it even more secure before you're using that on the URL side, in a query parameter or in a variable. So just many different ways that you could configure this for production as well. And you can also do integrations, authorization, routes, tons of different requirements that you might need. You'd be able to configure that with API Gateway. But yeah, just to show that now, even like if I try to do this more, it's still not going to work. And I could like try to spam it and it's still going to give me that error bad response, Axios error. So not bad. So this is great. So we just figured out yet another way for us to communicate with our SageMaker endpoint. So great job. And to make sure that we spin down all of the resources in our SageMaker studio, what we'll do is that we will go back to the SageMaker page in the AWS Management Console, and you would go to Studio if you don't already have this open. We already have our notebook open, so we could just click into this. So I will give this a refresh since I'm already logged in. But if you're not already logged in, you would just go to the page. So I see quite a lot of instances here, and these are going to be billing us at the same rates. So we have our running instance, which is the 12x large and also the medium. And then we also have these running apps. So what we're going to do is that we're going to remove these, and then we will shut this down. And that will be another way that we're able to then save costs. And something also that you might want to do is download your Jupyter notebook. So what you can do is that you press File, and then we'll do Download, and then we'll be able to save this to our computer so that we get to keep all of the data and all of the records of how we've used this model. And one of the best ways that you can continue to track costs is if you go to your homepage for the Amazon Web Services Management console and you scroll down, I have this very handy cost and usage widget, and this is very helpful for tracking costs over a period of time. So you're able to see really all of the costs that are incurring per day, and it'll give you the top costs per service and also give you expected values of what's going on. So this becomes very helpful because as I am trying to make sure that I'm managing costs as a cloud engineer, and as you'll want to make sure that you're keeping tabs on all the services that you deploy, because if you leave an instance running, that might be incurring costs at an hourly rate that might not necessarily be that bad if it's an hour or two, but if you leave it on for several days or let alone several months, you'll be racking up pretty significant costs. So this is where a widget like this becomes really helpful. And then of course you can go to the cost management tab and learn more about your spend and what that looks like, and you can sort of see your total cost expected per month, daily unblended costs, and a lot more information about basically your cloud spend and what you're expected to pay. So just be on the lookout for the widget and also AWS cost management so that you can make sure you don't get billed for resources that you're not using or get an unexpected bill and need to dip into your wallet when you don't want to do that. So hopefully this is also helpful for you to keep in mind as you work with these servers that can especially be expensive and costly if left unmanaged and or you forget about them and then they're just running. So we just went through a ton of awesome information, and I hope that this video was really helpful for you in understanding how we can take our SageMaker endpoint and then now start throwing that into a whole bunch of different types of applications. So those could be APIs, those could be serverless scripts, those could be application scripts, those could be applications specifically. And what's really cool about this is now that we can enable and mobilize our endpoint, we can now start enabling a lot of developer experiences around our model. And this is very cool too, because now what we can do is we can take basically any sort of request response pattern and then now throw that into the model. But instead of us directly hitting the endpoint, we sort of have this layer or this buffer between the user that's requesting information and then where our model lives. So you sort of have that buffer zone, and that's what's really helpful, because what we can now do is that you're not directly having access to the endpoint, you're directly having access to a service that could or could not have access to that endpoint. So when you think about security in the cloud or having sort of that least privileged access, this becomes very important, because now what you could do is that you could temper access to the endpoint. You could, configure routes. We also talked about that with API Gateway, where you could have a production stage and maybe also a development stage. And what you could do is that you could, determine what types of applications have access to which types of stages. And then also, for example, maybe in Lambda, you might want to have a Lambda authorizer. So that would allow you to gate access to calling this Lambda based upon certain things. So there's tons of these also services. Like you could also throw in AWS AppSync. That's another type of API that's more on the GraphQL side. And you'd be able to then configure auth directives around your API, for example, or calling a Lambda that hits the API and then gets data back. So a lot of really great considerations around how you can build applications. Also, very cool, we were able to build our own Llama chat application and show how with Next.js and TypeScript and with Tailwind CSS, we'd be able to connect to our model and then build an application that allow a user to write in a prompt, press a button, and then get a response back from that model through our API. So a lot of really great learnings from this video. I hope that this video helps you on your AI and ML journey. And of course, if you'd be able to like and subscribe to this channel, this would help us immensely and help us allow us to create more content for you all based upon what you want to know. So with that, I will let you all go off to continue on your building journey. Again, thank you so much for watching this video, and wherever you are tuning in from in the world, I hope you have a great rest of your day, afternoon, or evening, and I'll see you all next time. All right, thanks everybody. Bye.